This video will review how we write polynomials if we are given the zeros, and also what the multiplicity is and what it means. All right, so we're going to start out just writing a polynomial from given zeros. Keep in mind that if we have any complex roots or irrational roots, they have to occur in pairs. For example, if 5i is a root, then negative 5i is implied. It won't always say it, but we have to know it's there. Same thing with irrationals, like a square root of 3, then the negative version is also implied. All right, so we are given three zeros, a 3, a negative 3, and a 4, and we are asked to write a polynomial function whose rational coefficients, with rational coefficients, so that the polynomial is equal to 0 at those roots. All right, so the first thing we start with is what are the zeros, and we are given those, a 3, a negative 3, and a 4. From each of those, we are going to make factors. So if 3 is a 0, it came from a factor of x minus 3. Right? Picture dumping a 3 in for x, it creates a 0. If negative 3 is the 0, it came from the factor x plus 3. And if 4 is a 0, it came from the factor x minus 4. And now we just have to multiply those together to get our polynomial. So p of x, I'm going to FOIL the first two. Those are conjugates, so the middles are going to drop out. X minus 3 times x plus 3, when we FOIL it out, gets me x squared minus 9. I still have the x minus 4 to multiply in. I'm going to do that as our next step. We are going to be FOILing this out. So x squared times x gets me x cubed. Outsides gets me a negative 4x squared. Insides, a negative 9x. Notice those are not like terms, so we can't put those together. And then our last term would be negative 9 times negative 4, or positive 36. And there is a way you can check your answer. You could type that in your calculator and graph it. It should be touching the x-axis at a 3, a negative 3, and a 4. So that's an easy way to check your work. All right, our next example. We have zeros of 1, negative 2, and 7. So our factors are built off of those. If 1 is a 0, then x minus 1 is the factor. If negative 2 is a 0, then x plus 2 is the factor. And if 7 is a 0, then x minus 7 is a factor. Now for this one, I am going to have to just, it doesn't matter, I have to pick two of them to multiply together first, and then I can put the third one in. So I like to multiply the second two first and keep the smaller one up front. When I FOIL these second two factors together, x times x is x squared. Outsides are negative 7x and insides are 2x, which combined puts it at negative 5x. And then my last term, 2 times negative 7, would be negative 14. And now I can go in and multiply the x minus 1 in. So I'm going to multiply x to that trinomial. So x times x squared would be x cubed. X times negative 5x is negative 5x squared. X times negative 14 is negative 14x. And now I have to go back and do the same exact thing with the negative 1. So I'm going to take negative 1 here and multiply it to each one. So negative 1 times x squared is negative x squared. Negative 1 times negative 5 is positive 5x. And negative 1 times negative 14 is positive 14. And now I just want to clean it up, combine any like terms. So I have an x cubed. I have a negative 5x squared and a negative 1x squared, which would be negative 6x squared. I have a negative 14x and a 5x, which is going to get me negative 9x. And then I have a constant of 14. So again, I could graph that on my calculator and check that it is hitting the x-axis in those three spots. All right, the last one, we do have some irrational and complex answers. Or sorry, roots. So if the zeros are roots, I have a square root of 2, then it is implied that I also have the negative square root of 2. If I have a 3i as a 0, then I also have to have negative 3i. So that's what I was talking about earlier. They have to occur in pairs. So now my factors, if the square root of 2 is a 0, then x minus root 2 would be the factor. If negative root 2 is the 0, then x plus root 2 is my factor. If 3i is a 0, then x minus 3i would be the factor it came from. And if negative 3i is the 0, then x plus 3i is the factor it came from. So again, notice that those are occurring in conjugate pairs for my factors. Then to multiply everything, I am going to choose to multiply conjugates together first. So I'm going to do those two together, and I'm going to do those two together. And then I'll put it all together at the end. So x times x is x squared. With conjugates, your insides and outsides are going to cancel each other out. And we have a negative root 2 times a positive root 2, which ends up being a negative root 4, and the square root of 4 is just 2. All right, multiplying my second pair. So looking at those two, x times x is x squared. Again, insides and outsides are going to cancel each other out. My last term is negative 3i times 3i. That's negative 9i squared. But we have learned that an I squared is really a negative 1. So I'm going to rewrite this x squared. Instead of negative 9, I'm taking negative 9 times negative 1, which makes a positive 9. All right, and now I need to FOIL those together. So p of x equals x squared times x squared. All right, first term is going to be an x to the 4th. Outsides is 9x squared. Insides, negative 2x squared. And last would be negative 18. Combining my like terms, I have the polynomial x to the 4th plus 7x squared minus 18. Now, if we were to graph that, we are going to see x-intercepts at the root 2 and the negative root 2, but we would not see the imaginary ones. All right, the last piece that we are going to look at is multiplicity. Multiplicity refers to the number of times a factor appears. So if a 0 has a multiplicity of n, it means that the factor x minus a appears as a factor n times. If the multiplicity is odd, so we end up with a multiplicity of 1, 3, 5, etc., the graph is going to cross the x-axis at that 0. If the multiplicity is even, the graph is going to touch the x-axis and then turn around without crossing it. Okay? So an odd multiplicity, we would have a graph crossing. An even multiplicity, we would have it touching and then turning back around. Okay? So the fact that it crosses there, I know that has an odd multiplicity. The fact that it's just touching and turning back around, I know that has an even multiplicity. All right, so we are going to look at our polynomials already in factored form, which makes finding the multiplicity much easier. It says to find the zeros, state the multiplicity, and look at the behavior at each of those zeros. So my first chunk here, the 3x squared, I look at what makes that piece, that factor, 0, and the only option would be if x is 0. Okay? Then I look at the power. All right? That x is in there twice. It's an x squared. So it has a multiplicity of 2, and because that is an even multiplicity, we are going to say it touches and turns. Okay? It's kind of like a parabola. All right? It's going to touch down and turn back around at that 0. My next piece. I have an x plus 2. Notice that it is showing up as a factor 3 times. So what makes it a 0 would be a negative 2, but because it's occurring 3 times, my multiplicity is 3. And since that's an odd multiplicity, it is going to cross the x-axis at that spot. And then the last piece, the last factors, we have a 3x minus 4. I need to figure out when 3x minus 4 creates a 0. So I'm going to add the 4 over, divide out the 3. So my 0 would be 4/3, and it's in there twice, so its multiplicity is 2. And then because it's an even one, it touches and turns. Okay? Our next example. Again, we have three parts. So that first one, the only thing that makes that a 0 is if I put a 0 in. It has a multiplicity of 3 because it's an x cubed. And because it's odd, it is going to cross the x-axis at that spot. Our second one, what makes that 0 is a 4. It has a multiplicity of 4 as well, a power. And because it's even, it touches and turns at that value. And then my last one, the power is a 5, so I know its multiplicity is 5. I do need to figure out what makes it a 0, so I'm going to subtract the 5 over and divide out the 2. So negative 5 halves would be my 0. It is in there 5 times. In other words, that factor of 2x plus 5 occurs 5 times. And because it's odd, it is going to cross at that point. All right, hope that helps your review.